Today we're going to be talking about digit problems. Before we begin though, we must first understand the difference between the word digit and number. And there is a very big difference. When you're talking about a number, you're talking about an amount with value. For instance, if you have a 3-digit number, your number can have value in the hundreds, the tens, and the units place. A digit is just a symbol that we use to make numbers. And in our number system, we have 10 different digits. These are symbols that we use, and they begin with 0, 1, 2, 3, all the way to 9. Each one of those symbols is a digit. I'm going to make an example of how we can use digits to define a number. If we pick 3 different digits from the list, let's say we pick 1, 0, and 5, we can make the number with the value 105. The number 105 has 100, 0 tens, and 5 units. Altogether, it makes a value of 105. Okay. We can also reverse the numbers, reverse the digits to make a number worth a different value. Reversing the digits 5 and 1, we now have 5 hundreds, 0 tens, and 1 unit. The value of this number is different. Even though we use the same digits, all we did was we changed the order of the digits to change the value of the number. So using that example, we can say that using the digits 0, 1, 3, we can make the numbers 15, which consists of just 1 10 and 5 units. You don't have anything in the hundreds place, so that would be 0 hundredths. And make the number 15. We can also change the order and make the number 105, which consists of 100, 0 tens, 5 units. Okay? And we can continue to do that and look at all the different variations of numbers using these same 3 digits. So if you're starting to understand what the difference between a number and a digit is, my favorite example to use is a phone number. Phone number, if you're dialing within a city, has 7 digits. You talk about numbers, and when you read phone numbers, you read the numbers individually. You don't say, my phone number is 2,700, blah, 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 blah. What you actually say is my number is 270, blah, blah, blah. Okay, so the difference between a digit and a number has value, digits are just symbols. Okay, now that we understand the difference between that, we talk about some more vocabulary. What happens when we change the order of digits? Well, changing the order of digits, we said, can change the value of a number. And in these problems, I want to highlight some vocabulary words that you might encounter because it will cue you to change the order of your digits. Some of those words are reverse, interchange, or switch. Whenever you see any of these words, it means you're going to change the order of the digits, and that may change the value of the number. So just keep that in mind. So we're going to start off with our very first example. Example number 1. The sum of the digits in a 2-digit number is 10. The new number obtained when the digits are reversed is 18 more than the original number. Find the original number. Okay, give me a second to write that down. So I want to set up this problem first by understanding that We are looking for the original number. And this is a 2-digit number. This is very important to know because from this information, you can imagine in your mind that there will be 2 digits in your number. If there are 2 digits in your number, one will be the tens place, one will be the units place. Okay? We don't know what that number is. It could be 12, could be 54, it could be 99. We don't know what that is. So we are going to let x equal the tens digit, and we will let y equal the units digit. Once we are able to solve for both x and y, we can put them together to create the number. But for now, we don't know what it is. We will define the variables as x being the tens digit, y being the units digit. So, I'll actually write in x and y so you can imagine this number. Okay, so this is the original number. Okay. Taking a look at the very first sentence, the sum of the digits in a 2-digit number is 10. We can already translate that and say that x plus y equals 10 is one of our equations. Sum meaning we're adding the digits, we're going to get 10. Taking a look at the next sentence, the new number obtained when the digits are reversed. Remember, reversed is a cue word for you to switch the numbers. So let's write down our new number. Let's see what our new number will look like. New number will still have 2 digits because they are the same digits. We're just reversing the order. So our new number will be y. Okay. So it says here the new number obtained when the digits are reversed, and you see we reverse the digits, is 18 more than the original number. And we want to find our original number. Okay, let's go back and take a look at what the value, because it's talking about number, you always want to look at the value of the number. Let's go to our original number. The value of this number is x tens. We don't know how many tens we have, but we know that there will be x amount of tens. And that's going to be added to y number of units. Okay, well, we know that tens is just 10, the value of 10, and y units is just worth 1. So our original number then is actually 10x plus y. Okay, let's take a look at the value of our new number. We have y tens plus x units. Okay, so y times 10 plus x times 1 will be the value of our new number. Simplifying that, we'll have 10y plus x. Okay, so keep this in mind. We have the value of our new number, the value of our original number. We're going to use these to translate the second sentence. Let's read again. The new number obtained, okay, I'm going to underline that value because the new number, okay, so our new number here is 10y plus x when the digits are reversed is equals 18 more than the original number. We said 18 more than, so we know that 18 is going to be added to our original number. Well, what was the value of our original number? Our original number is right here, 10x plus y. We're going to add 18 to that. Okay. Using this setup, we have been able to identify 2 of our equations, which we will go ahead and solve. I'm going to do this on a separate sheet of paper. Let's rewrite this again. We have x plus y equal to 10, and we also have 10y plus x equals 10x plus y plus 18. Okay. So first thing I'm going to do is I'm going to get all the variables to one side. I'm going to subtract 10x from the right, and I'm going to subtract 10x from the left. That will leave me with negative 9x plus 10y equal to y plus 18. Now I'm going to move over the y's. Subtract y, I will have negative 9x plus 9y equal to 18. So here's one of my equations. I'm going to rewrite this equation underneath. Okay, x plus y equal to 10. So there are a lot of different ways that you can go about solving this. I'm going to use elimination with multiplication. So if I multiply this entire equation by 9, remember you have to distribute the 9 throughout the entire equation, I will have 9x plus 9y equal to 90. Let's rewrite that equation right underneath. And I can now eliminate. I'm going to eliminate the variable x, leaving me with 18y equal to 108. Dividing by 18 y will give me a value of, let me divide, I think that's about 6. So 6 times 8 is 48. The 4, 6 times 1 plus 4 is 10. So yes, y is equal to 6. But we're not done. We always want to solve for the second variable. So if we know that y equals 6, we can plug back into this equation. Y is 6, well, x must be equal to 4 in order to add up to 10. So we have y is 6, x equals 4. And we're going to test this to see if it works, okay? To make sure, well, first let's answer our question. The question was, find the original number. And our original number, if you go back to our setup, is x, y. So here we have our number, the original number is x first, so 46. Original number is 46, and we of course want to double check to make sure that our answer is correct. If we add the digits 4 and the digit 6, do we get 10? Yes, we do. And let's think about what happens when you reverse the digits. If the reverse number is reversing the digits, you get 64. Let's see if 64 is indeed 18 more than 46. We have 64, subtract 46. Let's see what happens. 18. So yes, this was correct. Our original number is 46. Reversing the numbers, you would get 64, which is 18 more than the original number. Okay, so we have defined our variables. We have translated the question into two equations. We have solved for our equations, we have answered the question, and we have checked our work. 5 steps. Let's try this with another example. Example number 2. A 2-digit number is 7 times the sum of its digits. The tens digit is 3 more than the units digit. What is the number? And again, I want to break this down. Let's imagine our original number. We're going to have a 2-digit number once again, 2-digit number, so we know that we'll have a number in the tens place and a number in the units place. Okay, and again, we don't know what that number is, so let's define our variables. Let x equal the tens digit, and let y equal the units digit. Okay, we'll keep this in mind. So looking at our original number, if I put in x and y, I once again have x values in the tens place, and add that to y values in the units place. And x times 10 plus y times 1 is just 10x plus y. So this is the value of my original number. Okay. So it says here, a two-digit number is 7 times the sum of its digits. The sum of the digits is x plus y. And a two-digit number, well, here's our two-digit number. Remember, the number has value, has place value considered. So I'm going to write 10x plus y is equal to the sum of its digits, 7 times the sum of its digits. So sum of its digits, 7 times. That means that when I multiply, I'm going to have to remember to distribute. Okay, so here's my first equation. My second equation says the tens digit is 3 more than the units digit. Here we're talking just purely about digits. Okay, so the tens digit, x, is 3 more than, so it is 3 more than the units digit. And the units digit we have represented by y. So here's my second equation. Okay, so let's simplify and solve. I'll use a separate sheet of paper. I have x plus, we have x equals y plus 3, and we also have 10x plus y equals x plus y times 7. So let's distribute and simplify. 7x plus 7y. I'm going to get all the variables to one side. Okay. Subtracting 7x, 3x plus y equals 7y. I'm going to subtract 7y. 3x minus 6y will be equal to 0. Okay, so I think because I have x equals here, I'm going to use substitution. I'm going to substitute y plus 3 in for x. So 3 times y plus 3 minus 6y will be equal to 0. Okay, so 3y plus 9 minus 6y equals 0. I have a positive 3y and a negative 6y, so I'm going to have negative 3y plus 9 equal to 0. Let me move this up. So subtracting 9 from both sides, bring it over here. Negative 3y will be equal to negative 9 dividing by negative 3. Y will be equal to a positive 3. Well, y is equal to a positive 3. You can see that x will be 6. Okay, let's stop and make sure we answer the question and also check our work. Okay, the original number we said is x, y. So that means that our original number, is 63 as x and then y. Okay, so let's double check. Two-digit number is 7 times the sum of its digits. If we add these digits together, we get 6 plus 3, which is 9. 9 times 7 is 63. So the number is 7 times the sum of its digits. The tens digit is 3 more than the units digit. Now, 6 is 3 more than 3. So it checks out. So that's the answer for example number 2. What I'd like for you to do before you come into class tomorrow is to try this example. The sum of the two-digit number is 7. The new number obtained when the digits are reversed is 27 less than the original number. Find the original number. Okay, and so now underline some keywords, reverse and less than. Remember what you need to do whenever you see those words. Okay, and bring that in with you tomorrow and we will cover it then.